Alright, well, hello and welcome to example 2, where we're going to solve the following differential equation. So we have 2y sine x cosine x minus y plus 2y squared e dxy squared dx equals x minus sine squared x minus 4xy e to the xy squared dy. They're a mouthful. So the first thing we would do is we want to get it of that form, m dx plus n dy equals 0. So I'm going to bring everything over to the left-hand side, and when I do that, I'm going to have 2y sine x cosine x minus y plus 2y squared e to the xy squared dx. Now, I have to bring it over. I'm going to minus everything, but again, I want, so I'll just do this minus. Then I have x minus sine squared x minus 4xy e to the xy squared dy, and that's equal to 0. The thing, though, is in the form it had to be addition, so one thing that I'm going to make sure that I do is I'm just going to distribute the negative so I can make it plus, so negative plus plus. All right, and so there is my differential equation. Now, I want to see if this is exact. So again, I need to denote what is m, what is n. So here's our m, here's our n, and I want to see m sub y is equal to n sub x. So let's take the derivative of this with respect to y, and it looks like we're going to get 2 sine x cosine x minus 1, and then it looks like we're going to have to do a product rule, so it's going to be 4y, oops, got the plus 4y e to the xy squared plus, and then the derivative of e to the xy squared, so it's 2xy e to the xy squared times 2y squared. Now let's do n sub x. And so there's a lot of parts where you could really mess up here. So minus 1, derivative of sine squared x is going to be plus 2 sine x cosine x plus another product rule, derivative of 4xy is just going to be 4y e to the xy squared, and then plus the derivative of e to the xy squared is just going to be y squared e to the y squared times 4xy. And let's see if everything adds up. The 2 sine x cosine x goes there, negative 1, 4y e to the xy squared, 4y e to the xy squared. So you have a 4, they have a 4 up there, have an x and a y, have an x and a y, have a y squared, so all that checks off there. So we're good. We have an exact equation, and now what we're going to do is we're going to work on one of these. We can either work on the left side or we can work on the right side. I want to work with m. So what I'm going to do is I'm going to find my f of xy. I'm going to set that equal to the integral of m dx plus g of y. All right, so let's go ahead and now we're going to take the integral, but this time with respect to x. And so we have our m. Now I guess I'll write it out. So I have 2y sine x cosine x minus y plus 2y squared e to the xy squared dx plus gy. All right, so this first one right here, what you could do is you could break it apart. You know what, I'll do that because I think so there are some people who are having trouble seeing me do the U substitution rather quickly. So let's just go ahead and break this apart. And let's say we have the integral. So I'm going to put out all my constants outside an integral. So the integral of sine x cosine x dx minus y, the integral of dx plus, and then I'm going to put, I'm going to keep this there inside. There's a reason why. 2y squared e to the xy squared dx plus gy. All right, now for this first part, all right, I'm going to say u is equal to sine of x and du is equal to cosine x dx. So this first part can be written 2y, the integral of u du minus, that the next one's easy. So it's just going to be yx plus, and then I'm also going to do some more u substitution, but I'm going to make u equal to e to the xy squared, and I'm going to make du equal, and then, actually, I'm sorry, I'm going to make u xy squared. I'm going to make du just the derivative of that, but with respect to x, so that's just going to be y squared and dx. So then what I have is plus 2 the integral of e to the u du, then plus g of y. And so then my final answer over here is when I integrate u du, I'm just going to get 1/2 u squared. So I'm going to get 2y times 1/2 u squared minus yx plus 2 e to the u plus g of y. I'm going to replace all those things now. So then f of xy is just going to be 2 times 1/2 is just that, so y times sine squared x minus xy plus 2e to the xy squared plus gy. All right, now let's go ahead and take the derivative of that. So partial of f, but with respect to y. When we do that, we're going to get sine squared x minus x plus the derivative of that is going to be 4. So 2xy, so 4xy e to the xy squared plus g prime of y, sorry, g prime of y. Now, this equals, let me make sure that nobody gets that confused. That equals what our n value is, and our n value is negative x plus sine squared x plus 4xy e to the xy squared. Hopefully you notice, oh wow, a lot of things are going to cancel out. Pretty much everything is going to cancel out, and g prime of y is equal to 0. Integrate both sides with respect to y, so g of y is equal to just c. Now we can go ahead and replace that, which you can't really replace that. So now we're going to put this into our function, which our function is given by right here. So we're just going to substitute everything in. So we can say our final answer, which is f of x, y, is equal to y sine squared x minus xy plus 2e to the xy squared plus c, which again, now it's just going to equal c. And we've solved for the differential equation.